Hello, dear professor, and the rest of the people that are watching the video right now. Today we're coming back with a new presentation on evaluation metrics this time. We'll discuss all the limitations that we have. Here's all of them. This is flexibility of the robot, manual errors, angle of the camera and how it retrieves the data, manual storage implementation, the fact that storage is glued to one place, and some of the problems with arms and hardware of our system. First of all, let's talk a little bit about the lack of physical flexibility. What it means is that our in current stage of the project, robot and all the components of the project are glued to one place, and there is not really much robot can do with its tracks, and also it needs to be manually adjusted every 1 to 3 games to make it work properly. Also, there are some occasional magnet errors. This means that in some cases there is a little chance for O figure to be dropped from the arm while picking up. This is mainly due to the size of the O figure and its proportions to the cell. Also, there is a little problem with camera angle. If there is something in the background of the playground board, the camera is not detecting it properly and not displaying the 9 cells of the playground board. Here's the contrast. On this picture, you can see that there is nothing in the background and 9 cells are detected properly. Here I intentionally put my leg and playground board is not detected anymore.
Greetings everyone. I will continue with the manual storage implementation issue. Well, as we discussed before, we have basically 2 storages, one for playground and one for storage itself. So in our storage board, we have the figures X and O predefined before. Like first of all, if we consider this cell, which is basically located on the 0 row 0 column, till the row 1 and column 1 we have X's filled, and after that we have only O's. Well, which problem will occur with this kind of method? Well, basically, if someone wants to play TicTacToe and is not aware that the storage board is actually predefined, it will want to play again and may clean the board in the store the figures in the storage board in the chaotic ways. So next time when player makes the move, robot may pick up. For instance, if we wanted to pick up the O figure, it will pick up the X figure. And the next conflict is arm servos conflict. Well, what happens here? We try to do our arm manipulation based on the kinematics purely, but what problems occur there? Our servos are connected to each other in series, and this creates some sort of arm override, arm conflict. Well, suppose we want to move our arm to some predefined cell, but if we were willing that this servo should move faster than this one, sometimes this servo moves, but this one does not, or this moves and this one moves after this finishes his rotation, and it creates some sorts of unwanted outcomes. We basically overcame this issue by explicitly setting the stages and positions at which the servos move. So basically we give the priority to the home servo. Then if we are going to move from home position to the picking position, first we move this S S8 servo, and after that S7 servo will be moved, and vice versa when we return back home. Also, of course, we could implement it more gently with setting up some time and rotations based on the angles of the servo, but we decided to pick up the easiest way since the project itself is quite easy. And also one problem with servos is overheating. Well, if you want to play continuously with the robot, and as you probably know that when you are in the interactive mode, the robot utilizes the minimax algorithm, which is wrote so and works in a recursive way that it will either win you or either will result in a draw. So you get mad, you get angry, you want to win this freaking robot, but unfortunately you cannot. And after several tens or 20 of games, the servos may overheat since the arms are extended, and from the factory they were not supposed to handle this length and this weight that creates from this leverage. And it starts to overheat and may ruin the components of the servo, which will result in the complete stop of the robot. So hardware limitation, one more limitation that we faced is the overheating problem and stalling problem. Well, the Raspberry Pi, although it's quite powerful microcontroller, small computer, it sometimes suffer with the work of rendering. And as you know, we use the OpenCV in our project, and we constantly require the camera input to the system. The graphics are too hard for our Raspberry Pi, and the CPU usage level and also the heating of the CPU rises up to 100%. Well, we mitigated a little bit this issue by introducing the fan to our system and encapsulating the Raspberry Pi into the case, and we managed to drop the overheating by 2 or 3%. Although this is quite enough for scope of our project, but if we want to expand in the future, this may create some problems. And as I said, if we want to expand, this is what we would add if we had more time or want to just easily expand our project. First of all, why not to add a robot self-calibration? It may become overwhelming sometimes to calibrate the robot manually after 2 or 3 games. And since the robot makes a little jiggling, it's victory dance. After each time it wins, it offsets its position, and you have to calibrate it yourself. So robot can utilize different methods, either LiDAR or ultrasonic sensor, to calibrate itself correctly to the relation of the boards. Second is the storage board camera detection. As I said before, we have the figures predefined on the storage board, and therefore if the user, which is not aware of that, cleans up the board and stores the figures in the storage board incorrectly in chaotic order, the robot may pick up the wrong figure. Third thing that we would add is the HD camera, small HD camera mounted on the top of the robotic arm. Why this gives us mobility? Since our set itself is quite not mobile, located on one side, it may create some hindrance in the perspective of another game. Suppose we want to make a project with Transbot another game, and we have to plug up and plug in the USB cable of the camera. It's better to have one small camera on the arm. And of course, board cleaning, as I mentioned before, it's always be better that if robot does the job instead of human, and it could simply clean the board after each game played. So basically that's it. Hope you enjoyed. So thank you, and see you on the next presentation, on our final presentation, where we show the entire project. Hope you enjoyed. Thank you.